Let's try to solve this problem here. So a transparent film of n is equal to 1.43 is deposited on a glass plate, which is n is equal to 1.52, to form a non-reflecting coating. So the idea of deposited means by you are going to apply it on the glass plate over here. So you should expect that this transparent film is on top of a glass, and this transparent film has purpose to form a non-reflecting coating. Okay, so maybe we can draw the 3 layers first. Okay, so you know that the thin film over here is this transparent film. Okay, this will be our thin film and it's applied on the glass plate. So the glass plate will be below it because you're applying on top. So what's the first medium above the transparent film? Well, there will be air, right? Because you're shining light from air hitting onto the transparent film. Okay, so these are the 3 mediums that we have. Let's label the index of refraction. 1.00 for air, 1.43 for transparent film. Glass plate is 1.52. Okay, so now we know the 3 layers. What can we do is we can determine their phase change, how many phase change occur over here. So the first one, you go from the first boundary, you go from 1.00 to 1.43. So you go from low index of refraction to high index of refraction. Yes, there is phase change. Go from low to high, there is phase change. For the second boundary over here, between transparent film and glass plate, we look at this boundary over here, we go from 1.43 to 1.52. So again, it's low to high as well. So we can also say that here there is phase change as well. So this is a situation involving 2 phase change. So there's 2 phase change happening over here. And what do they want? Do they want constructive or destructive? Let's look at the question once again. They want to form a non-reflecting coating. The word non-reflecting means by we want to minimize reflection. Okay, so if you want to minimize reflection, the idea of minimizing reflection means by you want it to disappear, right? Okay, you want to minimize reflection, you don't want to see too much reflection. So if possible, you want the reflection to cancel out. If you want the reflection to cancel out so that you minimize it, cancel out, the idea means by you want to destructively interfere the light. So this will be destructive interference. Okay, so 2 phase change, destructive. Okay, again we have to think we are going to flip the equation twice because there's 2 phase change. We are going to flip twice. Okay, so let's start. The constructive is m lambda, the destructive is m plus half lambda. You are going to flip twice. So the first flip will cause constructive to be m plus half lambda, destructive to be m lambda. But now you flip once again, and now constructive will be m lambda, destructive will be m plus half lambda. So the equation we want destructive with 2 phase change, so it will be plus half lambda. So this is 2nt is equals to m plus half lambda. This is our equation to be used. Okay, so it's always important that we determine how many phase change happen and whether you want it to be destructive or constructive. From there only we are able to pick the correct equation. Okay, so if we substitute here, we can see that we have the thin film index of refraction, which is 1.43, and we also have the thickness of the coating. The thickness of the coating or the thickness of the film is 1.07 times 10 to the power negative 7. So let's substitute everything that we have. 2, 1.43, 1.07 times 10 to the power negative 7. Okay, next you have your m plus half lambda over here. The idea here is they want the longest possible wavelength. So they want to maximize the wavelength in vacuum. So lambda here should be a maximum value. Okay, you know that you can do nothing to the left hand side over here because 2nt, all the values are fixed. So what you can manipulate is between m and lambda only. So if you want to maximize your lambda, you will have to minimize your m, right? Because by minimizing m, you can bring the lambda to a larger value. Okay, so what's the minimum m you can substitute here? Well, you can consider 0 then if you think about it, if you substitute 0, will it cause a 0 thickness? No, okay, because 0 plus half will be 0.5, so there's a certain value to it. You will not get 0 thickness. So m is equal to 0 is a safe number to substitute, and it's the minimum value that you can substitute. So you're going to substitute 0 over here in order to obtain lambda max. So you substitute 0 over here, you get lambda max to be equals to 612 nanometer. Okay, so this is the longest wavelength that will be cancelled out if you shine on it. So 600 is somewhere near orange or red, somewhere around red or orange, somewhere around there. So if you shine red light or orange light on it, that reflection will probably be much weaker because those light will be cancelled out. It will be destructively interfering. Okay, so this is a practical example of how we use this kind of thin film in daily life, in which we apply it to cancel out a certain kind of reflection. Okay, why do you want to cancel a certain kind of reflection? There's many ways to think about it. If you talk about your eyes, your spectacles, your specs, it might be to cancel out your reflection of your own eyes. When you're looking outside, you don't want to see your own eye reflection, right? Okay, so those kind of coating will be to cancel out the reflection of ourselves. If you look at our phone screen, let's say phone screen, we don't want to look at our own face reflection from the phone screen, right? We want to look at the screen itself, the user interface of your phone. So in that case, your thin film might be applied to cancel out your own reflection. Okay, so different purposes for different situation. Sometimes we need non-reflecting coating because we don't want to see the reflection. So those are those situations we need non-reflecting coating. Okay, but there are also certain situations where we need reflective coating. So we want to maximize the reflection that we can see. Okay, so what kind of situation, I'm not really sure, but there are situations where they need reflective coating. There are situations where we need non-reflective coating. So it's a case by case basis. So if you read the question, you try to understand the intention of the question, whether they want it to be constructive or destructive, and once you determine how many phase change, you will be able to solve the question rather easily. Okay, so that's it for this question. Thank you very much.